Hi everyone, my name is Amitesh and in this video we're going to master implicit differentiation. It's a walkthrough on the following question. Find dy dx when log of square root of x squared plus y squared is arctan y over x. And it's going to involve all the fundamental principles of implicit differentiation as well as differentiating arctan. So it's an all-in-one problem. A subscriber actually suggested this problem to me. It's from one of their past exams and I wanted to support them, and I also thought this is a great question. So if you're interested in my content, please don't forget to like and subscribe, and let's just dive right into it and try to understand the process. Okay, so first I want to walk through the process of implicit differentiation. So what is implicit differentiation? Well, the idea is that y is expressed, y and x are related by this equation, but it's not y equals something. So when we're doing this, we have to take into account two steps. So step one is going to be the following. We want to differentiate, and remember to multiply by dy dx every time we differentiate a function of y. So differentiate plus multiply by dy dx every time we differentiate a function of y. Okay, so that's the first step. Every time we differentiate a function of y. And what is a function of y? It can be anything, right? So it can be y squared. For example, in this example, we're going to have y squared. Y itself is a function of y. The whole thing, arctan of y over x, is a function of y and x. But we have to basically do that, and we'll walk through the process. Okay, so don't worry, but I'm just outlining the steps here. And step two is going to be solve for dy dx. Okay, so solve for dy dx. Now, I'll explain in detail why we're doing this, okay? So what's the reasoning behind multiplying by dy dx? It's basically the chain rule. So first of all, we have to master differentiation, which I assume that we've done, but I'll walk through all the steps. And we're going to use a lot of different cool things like the quotient rule, derivative of arctan, etc. So it's going to be super fun. The first thing I want to point out, and this is a simplification of the problem, it's a trick, okay? It's a secret trick. The secret trick is that log of square root x squared plus y squared, you want to basically simplify that because logs behave well with exponents. And when you see a square root, you see an exponent. It's an exponent of a half. Okay, so another way of writing this is I'm going to do each side separately. Okay, so I'm going to differentiate the left-hand side, then the right-hand side. So we're going to go one by one. So first of all, what I'm trying to say is that the log of the square root of x squared plus y squared is the log of x squared plus y squared power half. Okay, that's what we're actually doing. And why that's important is now the half comes out, so we just get half times the log of x squared plus y squared. And this is so much more convenient because if we have to differentiate the log of square root of x squared plus y squared, it's going to be the same answer, of course, but you have to differentiate a square root, which can introduce errors sometimes. So this is nicer. And now let's go ahead and differentiate. Okay, so we want to take the derivative of half times the log of x squared plus y squared. And I'm going to walk through the process. So how's this going to work? Well, the half is always going to just come out. It's a constant. So we multiply by the derivative of log of x squared plus y squared by a half. Now, how do we differentiate log of x squared plus y squared? We use the chain rule. Okay, it's something, log of something. How do we differentiate log of something? We differentiate the log, then we multiply with the derivative of the something. Okay, so we're just going to get here, we're going to get the half comes out, as I said, times, what is the derivative of log of something? It's 1 over the something. Okay, that's the log laws, the log differentiation rule. So it's going to be 1 over x squared plus y squared times the derivative of x squared plus y squared. What is the derivative of x squared plus y squared? So that's going to be, so I'm going to put that, underline that in red to show that it corresponds to that there. So the derivative of x squared plus y squared, derivative of x is 2x, that's the power rule. Derivative of y squared is 2y. But you cannot leave it like that, okay? So you have to multiply by a dy dx. And this is a point which can trick people up in the beginning. Why do you do that and forgetting to do that? So why you do that is that if we hypothetically could solve this equation for y would be some complicated expression in terms of x, right? Y wouldn't just equal x, right? I mean, this expression, y wouldn't just equal x. Y would be something complicated. So when you have something complicated, its derivative is not just going to be 1. It's going to be something complicated. And when you're taking the square of y, its derivative is not just going to be 2y. Because y is not just x. Y is something we don't know. So it's going to be 2 times y times the derivative of y with respect to x. So that is the reasoning there. So that's important. So we get this. And of course, now you can cancel off the 2's. You sort of see 2x plus 2y. Factor out a 2, cancel it off. And you're just going to get x plus y times dy dx divided by x squared plus y squared. Okay, that's going to be the first derivative we have here. And our next goal is going to be differentiating the arctan. Okay, so now that we've got that, let's now, I'm going to just like rub this off and record our derivative. Okay, so in these kinds of problems, I like to do things step by step, you know, because anyone can make mistakes. I emphasize this, you know, I've done calculus for a very long time. I've first learned calculus a long time ago. It's just calculational errors, okay? Even if you understand the principles, it really helps to just split things up. And this is why I say that, you know, I just find the derivative of the left-hand side, then I'll do the right-hand side, rather than do them each step equals. Of course, you can try, you know, you can always be brave. I'm not suggesting otherwise, but it definitely helps just to really be clear and make sure you're error-free to do things step by step. So that's the first derivative that we've got down there. Let's now do the arctan y over x. So we're going to recall what is the derivative of arctan. Okay, so this is, I'll have a video, okay? If it's out at the time I've uploaded, links will be in the description, or you can check out my channel. Check out my channel, you know, I've got content at all levels, constantly uploading math at all levels to help support you, okay? So subscribe, you know, it's like a cheat code to be exposed to math. But arctan, you know, let's just recall the derivative quickly. So arctan, I'm just going to say arctan of u, the derivative is 1 over 1 plus u squared. Okay, so in a video I'll explain why this is, but we're just going to take this formula, and I recommend, you know, remembering this. It comes up a lot in calculus. So whenever I've taught this at Princeton, you know, people were remembering it because, you know, we have this in exams, we had this in, you know, homework. So it's very important just to remember this, just to kind of be clear with it. It's an easier one to remember because it's kind of nice. So once you have arctan u, derivative is 1 over 1 plus u squared, what you can do now is you can differentiate the arctan of y over x. Okay, so arctan of y over x, what's the derivative going to be? So it's again the chain rule. So arctan of y over x, derivative is just going to be, again, you use the chain rule, it's arctan of something. So what you want to do is you want to differentiate the arctan first. So arctan u, derivative is 1 over 1 plus u squared. So arctan of y over x is 1 over 1 plus y over x squared. So it's y squared over x squared times the derivative of y over x. Okay, so times the derivative of y over x, and what's that going to be? So we can do this with the quotient rule. Okay, so it's a cool practice with the quotient rule. Remember what the quotient rule says. Differentiate the top, multiply with the bottom. Okay, so let's first do that. Differentiate the y, it's just going to be y prime, not 1. Okay, so it's going to be y prime or dy dx. So dy dx, multiply with the bottom, then subtract, differentiate the bottom, multiply with the top. Okay, so you differentiate the bottom second, that's after the minus sign. So you multiply with the top, so you've got y times the derivative of the bottom, which is just 1, because derivative of x is 1, divided by x squared. Now here, I'm just going to do this here and write this out this way. You can make a common denominator, right? You have 1 plus y squared over x squared. It becomes x squared over x squared. So x squared plus y squared over x squared. So you've got x squared plus y squared over x squared. So now x squared plus y squared over x squared. And now you can kind of see, you know, because both are living in the denominator, you can cancel these two off. Right? X squared and x squared cancel. And now your derivative is just going to end up being x times dy dx minus y divided by x squared plus y squared. Okay, x times dy dx minus y divided by x squared plus y squared. That's going to be the derivative of arctan y over x. Now we're going to see something really cool. Watch till the end. We're going to find a super cool formula for the derivative of y. And I really like this. So we've got this is going to equal to this, right? X plus y dy dx is x dy dx minus y, because the x squared plus y squareds on the bottom cancel. Okay, because we've set these equations equal, so the derivatives have to be equal. Okay, so now what we can do is we followed our whole laws with implicit differentiation. We just need to do step 2 and solve for dy dx. So now I'm just going to erase this, just keep what is necessary on the bottom. And we're going to now get this done. So let's finalize the answer. So let's now, and don't forget to leave a like. You know, if you watch this far, it really helps support my channel, and it's good engagement. It disseminates my videos to other people who can also benefit from them. So we've got x dy dx minus y over x squared plus y squared. So setting the two things equal, x plus y dy dx is going to equal to x dy dx minus y, because we just cancel the x squared plus y squareds on the bottom. And so therefore what we can do is we can put the minus y on the left hand side. So we get x plus y is equal to dy dx times x minus y. Okay, so what I've done here is, what I'm trying to do is the dy dx is an unknown, okay? Everything else is kind of known in some vague sense. So what we want to do is, we have the x dy dx, the y dy dx. I'm just going to do this in 2 steps actually, just to be clear. X dy dx minus y dy dx, just to show that we want to factor out a dy dx, okay? So we're going to get, if you think about any implicit differentiation problem, you're going to get a bunch of terms with the dy dx multiplied with them, and a bunch of terms without. And what you want to do is factor out the dy dx from those first bunch of terms, and then you're going to divide by whatever is left over on both sides to solve for dy dx. So here, the bunch of terms has been put on that side, so therefore x plus y is going to equal to dy dx times x minus y. And now we can solve for dy dx by dividing both sides by x minus y, and we're going to get the following. We're going to get that therefore dy dx is going to equal to x plus y divided by x minus y. And that is going to be our answer. It's so cool, like such a weird function. Log and arctan. Don't worry if they seem weird to you, because they seem weird to me too when I see them. I mean, of course you can understand them, you get used to them, but I don't really think about them too much when I do these problems. I just, use what I need to know about them. That's how math is. You compartmentalize what you need to know, but we got something cool out here. And that shows you, y was not something simple like just x. Otherwise, so dy dx is something complicated, so that's why we had to multiply with the dy dx throughout. We've executed our steps, we've solved this implicit differentiation problem. Now you may ask, the quick question, I'll do other videos on this, but you may ask, if the formula is in terms of y, how do I find the derivative at some value of x, right? How do I do that? Well, if you know the x value you want to find the derivative of, you plug that in into this, and then you find y that way. Okay, so you plug that in, and then you find out what y satisfies this equation. There could be multiple y's if it's an implicit equation. And then accordingly, if you know what y you want, if you want to find a tangent line, you plug in that y, and then you plug in to find the slope, and you solve that way. Okay, so we'll do problems like that on this channel. Don't forget to subscribe. Wish you all the best. Thank you so much for watching. I'm so grateful you've watched this far. Watch time really helps my videos. Sharing, liking. I'm trying to help as many people as possible, creating infinite, free, accessible math education at elite level, straight to your room. You're at high school, you're at college, it doesn't even matter. Wherever you are, whatever you're doing, you can just watch these videos from the comfort of your home, and I'm delivering the education to you, and I really want to help as many people as possible. So if you want to support my vision of changing lives through math education, please don't forget to leave a like, subscribe, share, as I've said. And I know everyone asked for this, but it really goes a long way to helping to grow my channel. I wish you all the best, good health, positivity, success, achieving all your goals. I hope I was able to support you in this video. You love this calculation, made easy, and I'm super excited to see you in the next video. Please take care.